Okay, so let's look at another example of applying the rational root theorem. Remember that the rational root theorem is going to tell us how we can find zeros of something like this huge mess, right? So remember, the possible roots are going to be all like the plus or minus all of the factors of the constant term over the factors of the leading coefficient. In this case, our leading coefficient is -2, and our constant term is -28, which unfortunately has lots of factors, right? 28 has factors of 1 and 28, 2 and 14, 3 does not go in, 4 goes in 7 times, 5 and 6 are not factors, so we have all 6 of these factors, and 2 of course just has the factors of 1 and 2. So if we list all of the possible roots according to the rational root theorem, we'd have plus or minus the constant term. So let's just go with all of the like ones in the numerator over each of these factors. So plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 1 over 4, plus or minus 1 over 28. I don't know why I skipped over. Let's change that. Let's go 7 next, just to go in order. Sorry. Plus or minus 1 over 7, plus or minus 1/14. Oops, my cat just touched on, went on the board screen. Plus or minus 1/28. So that's all of the possible roots with the constant term factor being 1, but we also have the constant terms factor of 2. So we have all these same ones with plus or minus, now we've got 2 over 1, plus or minus 2 over 2, plus or minus 2 over 4, plus or minus 2 over 7, plus or minus 2 over 14, and finally plus or minus 2 over 28. Now, some of these are repeated, right? Plus or minus 2 over 2 is the same thing as plus or minus 1. So we've already got that one. Same thing with 2/4 is the same thing as 1/2. So we've already got that one. 2/14 is 1/7, so we already have that one. And 2/28 is the same as 1/14, so we already have that one. The rest of these are all going to be possible roots. Okay, so we've got this top row plus these 2 additional, or actually 4 additional because plus or minus. So those are all of our possible roots. So if we go ahead and graph this, and I know you can't see all of this, but if we graph this function, we can actually spot some real roots. So I see -2, 0 is a root, and in fact it has multiplicity 2. And then I've got some irrational thing that I can't really write down exactly. Desmos is rounding to 3 decimal places. But 1/2 is also a root of some odd multiplicity. And then again, I've got some sort of irrational root here. So I can at least take away that I know that my zeros based on the graph must include -2 with multiplicity probably something even, and 1/2 with odd multiplicity. So how do I use that fact now to get all of the other zeros? Well, I'm going to start with the fact that -2 is a 0 with at least multiplicity 2. At least it's even, right? So that means x plus 2 squared must be a factor of f of x. And so, which of course is x squared plus 4x plus 4. So what I want to divide is I want to take f of x, divide it by this, and see what's left. Okay, so this is again going to be another big long division here. I'm taking x plus 2 quantity squared and dividing so I'm taking, I really should say it this way, I'm taking f of x and dividing it by x plus 2 squared. Why am I doing that? Again, because I know f of x equals x plus 2 quantity squared times something, and I need to know what that something is, right? So to solve for that something, I divide both sides by x plus 2 squared, and so I see that if I could take f of x, that's this huge thing, and divide it by x plus 2 squared, it will help me factor, and I'll know what the rest of this is. Okay, it's going to be something of 3rd degree because I know I've already used 2 of my 5 degrees. Okay, let's dive in. So x squared, how many times does x squared go into -2x to the 5th? Well, we'd have to multiply x squared by -2x cubed in order to get to the, right? So if I multiply this by x squared, that's how I'm going to get -2x to the 5th. But when I multiply, I have to multiply all 3 terms by this. So -2x cubed times 4x gives me negative 8x squared. And plus 4, hold on, sorry, not squared, right? X cubed times another x would be negative 8x to the 4th. Okay, sorry about that. And then I multiply negative 2x cubed times just 4. That's going to be negative 8x cubed. And so I'm lining up all of my like terms. And by the way, we should note here that if for some reason there was a missing, so say there was like no x squared term here, then you would hold the place by writing 0x squared when you go to do the long division. So you did learn about long division, believe it or not, in Math 100. So this is meant to just be a refresher. Although I do acknowledge that this is a tedious process. So we're now subtracting all these terms. That's going to change all the signs, right? That's going to make this a plus, and this a plus. So negative 2x to the 5th plus 2x to the 5th, that's gone. Negative 7x to the 4th plus 8x to the 4th is going to give me positive 1x to the 4th. And 10 plus 8 is going to give me 18x cubed. And now I pull down the next term, 53x squared. So now I ask myself, how many times, let's switch colors, how many times does x squared go into x to the 4th? Well, that's going to go in x squared times. And now I'm going to multiply x squared times all 3 of these terms to get the next row. So x squared times x squared is x to the 4th. X squared times 4x is going to be plus 4x cubed, and x squared plus times 4 is going to be plus 4x squared. Again, we now subtract, and when I subtract, that changes the sign of this to negative, this to negative, and this to negative. So x to the 4th minus x to the 4th is 0. 18x to the 4th minus 18x cubed minus 4x cubed is 14x cubed, and 53 minus 4x squared is going to be a positive 49x squared. Again, we bring down the next term and ask ourselves, how many times does x squared go into 14x cubed? Well, it's going to go in 14x times, and we multiply 14x times all 3 of these terms. So 14x times x squared gives us 14x cubed. 14x times 4x is going to give me 56x squared. And 14x times 4 is going to give me 56x. Again, subtracting is going to change all the signs. This is going to be negative, negative, negative. So these cancel. 49 minus 56 gives me negative 7x squared, and then minus 28x. And I finally bring down the last term, minus 28. And ask myself one more time, let's go to orange, I guess, how many times does x squared go into negative 7x squared? And the answer is negative 7 times. And yet again, we distribute the negative 7 times each of these factors, each of these terms, I'm sorry. And so we have negative 7x squared minus 28x minus 28. And so when we subtract, all of that goes away and we have no remainder, which is good because that tells us that this question mark is in fact this polynomial right here. So rewriting this f factored, I get this factorization here. And so I've done a lot of work here, but I hate to say it, but I haven't gotten any, well, I'm a little closer, but I haven't been able to factor this completely because now I'm still left with a cubic, and I don't have any way of factoring this thing. So unfortunately, I have to again apply the rational root theorem. And I already know that I have this other root, so I know there's a root for x equals 1/2. So that tells me that 2x minus 1 is a factor, right? So 2x minus 1 must be a factor of this. So now I've got to divide. So now I need to divide negative 2x cubed plus x squared plus 14x minus 7 by this other root I know exists, 2x minus 1. So now let's do that. So let's divide again by long division. If you haven't noticed, you obviously need another piece of paper for this problem for keeping track of notes. But here we go again. We're now multiplying or asking ourselves, what do we multiply 2x by to get to negative 2x cubed? So that's going to be a negative x squared. Negative x squared times each of those is going to give me negative 2x cubed plus x squared. When I subtract, that actually means both of those are going to cancel. And so I'm just bringing down the 14x. How many times does 2x go into 4x? That goes in 7 times. So I guess I was switching colors when I went to a next level. So that goes in 7 times, and I would distribute the 7 to both those terms. 7 times 2x gives me 14x minus 7, and I forgot in this last step to bring down the 7 as well since I didn't have any other terms. And so when we subtract, yet again, they cancel, and we're left with a remainder of 0. So what does this tell us? This tells me that f of x, which we knew already factored into x plus 2 squared, also has a factor of 2x minus 1. And what's left after we take out both of those, or all 3 of those factors, is just this negative x squared plus 7. So how do we find the roots? Well, we set f of x equal to 0. And from this root, we know x equals negative 2 is a 0. We already knew with multiplicity 2, so this is no new information. This factor tells us that x equals 1/2 is a root. Again, not new information. That had multiplicity 1. But this is the new information. Negative x squared plus 7 equals 0 means if I add x squared to both sides, 7 equals x squared. In other words, x equals plus or minus the square root of 7. And here are our rational roots that we didn't have before. And so if we look at the graph, right, we can see this was our negative square root of 7. This one's our positive square root of 7. So here we have our 1, 2, 3, 4 roots. This one with multiplicity 2.